Alright, so point slope form looks like this. Y, which will be a variable, minus y1, which will be a number, equals m slope, which will be another number, times x variable minus x1, another number. Alright, so for example, if I were to put numbers where the numbers go, you might have something like this. Y minus 3 equals 7 times x minus 12. Okay, that would be an equation in
point slope form.
And if I had an equation in point slope form, that would be telling me that one of the points on my graph is 12, 3. And it would also be telling me that the slope of my graph is 7. Alright, so the numbers in the position x1, y1 tell me one point that's on my graph, and the number in the position of m tells me what the rate of change or the slope of my situation is. Alright, so two things you're going to want to be able to do with point slope form. Number one, all of those contexts, all of those situations that we were able to find slope in, we should now be able to write an equation for in this format. Alright, so that's the first thing that's going to happen. The other thing that's going to happen is, given an equation in this format, we should be able to use that to make tables, to make graphs. Alright, so let's start with the first objective. Alright, this situation right here, you have a graph, you have some points on the graph, you want to write an equation for this graph. First, I'm going to need to figure out what the slope is. So, as I travel from negative 12, 14 to 0, 6, what's happening? Alright, first off, I know I'm going down, so I know my slope is going to be negative. And I'm going down from 14 to 6, I'm going down 8. And from negative 12 to 0, I'm going forward 12. Alright, so my slope will be negative 8 over 12, which simplifies down to negative 2 on 3. Or, as a decimal, it would be 0.6, repeating as a negative. Alright, so that's my slope. Then, to put something in point slope form, I only need to pick one point. So I can pick one of the 2 points that I already have, or I can pick the third point. Let me see if I use this one. And then I just use that format. Y minus the y value, so minus a negative 4, the same as plus 4, equals slope, negative 2/3, times parenthesis x minus the x value of my point, 15. Alright, so point slope form, simple as that. Point slope form is not the mathematician's favorite form because actually it's not unique. There's a bunch of different ways that you could write the same equation in point slope form. For example, if instead of choosing this point, I choose negative 12, 14, alright, then I would be saying y minus the y value, y minus 14 equals slope. Slope will be the same no matter what because we're talking about the same line, times x minus negative 12 or x plus 12. Alright, this is thus a different looking equation for the same exact line. Either one of these would be right. I could get even a third equation using the point 0.06. Alright, but anyway, that's the idea. If you don't have numbers on your graph, and you're going to have to use counting techniques to find the slope, so it looks like we're going forward 2 and up 1, 2, 1, 2, 3, 4, 5. Alright, forward 2, up 5. So that will be a slope of 5 over 2, or 2.5. That's my slope. Now I need to pick 1 point off of this graph. So if I choose this one right here, I'm going down 1, 2, and backwards 1. You are going to need to be careful. Slope, we do change of y over change of x, but when we're naming ordered pairs, x comes before y, okay? So I should be actually going backwards 1, -1, down 2, -1, -2. Is that point? That's the one I could use, or I always like to deal with my positives. So if I do this point, I'll have all positive numbers instead. Forward 1, up 3, 1, 3. That'll probably be the easier one to use. Okay? Writing my equation, we have y minus the y value. So y minus 3 equals slope, 5/2, times x minus the x value. If I had used my other point, we would have y plus 2 equals 5/2 x plus 1. Alright, and remember the pluses are because I'm subtracting a negative. Subtracting a negative is like adding. Alright, switching contexts. Easiest context of them all, if they give me the slope and they give me a point, the reason it's called point-slope form is that's all I need to write the equation. Y minus the y value equals slope times x minus the x value. Alright, that's an equation in point-slope form, as easy as it gets. Again, if you didn't write down in the beginning the formula, you might want to go back and do that, because this makes a whole lot more sense if you can stare at the formula and see where I'm fitting the numbers in, why I'm fitting them in, where I'm fitting them in. Alright, if I'm given 2 points, first I need to find the slope. So, slope would be 2 minus -19 on 16 minus -12 is 21 on 28, or that simplifies down to 3/4. That's my slope. And then I can pick either point to use to write my equation. So let me pick this point. Again, if I have all positive numbers, I prefer to use them because it doesn't give me the weird minus negative thing going on that I got to change to a plus. So y minus the y value, y minus 2 equals slope 3/4 times x minus the x value, x minus 16. All right, that's an equation through those 2 points. Why would we want to be able to find an equation? Well, you've already seen a whole lot of constructive responses that you had to do this year ask for an equation and then ask you to use that equation to get more information. All right, equations are probably the most powerful way to represent linear situations because you can find all of the x and y values in a situation using an equation. All right? A lot of the other things like tables and ordered pairs and even graphs only show part of the solution. Same as when we're dealing with slope. You want to pick 2 lines. My desire to pick small values is fighting with my desire to pick positive numbers. I'm probably going to use these 2 rows. So, distance from 25 to 57 is going to be 32. Alright, up 32. From there to there, the distance from 8 to 16 is plus 8. So my slope for this situation will be 32 over 8, which is just 4/1, or 4. Slope of 4. And then I can pick any one of these points, have my slope, pick 1 point, use point slope form. Alright, let me do one of my negative situations just for variety. All right, y minus the y value, y minus negative 19 equals slope 4 times x minus the x value, x minus negative 3. All right, point slope form. Favorite context, story problems. Jimmy shows up at work by 5 o'clock. He's able to take home $215 if he doesn't show up till 7 o'clock later. It's less than 2 hours. He only takes home $135. Write an equation to represent the situation. All right, remember I said if you got to write an equation in Algebra 1, it means you're going to have two values that are changing. So one value that's changing is 5 o'clock to 7 o'clock. And the other thing that's changing is dollars to dollars. All right, so 5 o'clock goes with $215. 7 o'clock goes with $135. Find my slope. From 5 to 7, I'm adding 2. From 215 to 135, I'm subtracting 80. All right, so my slope will be minus $80 for every 2 hours, or that will simplify down to minus $40 an hour. Okay? Every hour that he comes later, he loses another $40. Now, can we write an equation? Yes, that's my slope. So, and let me choose the first point, 5, 215. All right, so y minus the y value, 215, equals slope negative 40 times x minus the x value, 5. Write an equation to represent the situation, then use it to find how much will he make if he shows up at 12 o'clock noon. All right? So time was x. So I'm going to put in 12 o'clock for x. All right, and then solve this equation. Y minus 215 equals negative 40 times 7, negative 280. Add 215 to both sides. Y equals negative 65. All right. If Jimmy doesn't show up to work until 12 o'clock, he's going to have to give $65 to the boss rather than the boss paying him. All right. So Jimmy better show up before 12 o'clock. Okay. All right. If you want to go backwards, you're given a equation in point slope form and you want to put that onto a graph. All you really need to do is identify the point. So the point is 2, 3 for this top equation. Forward 2, up 3. All right, we know that that's one of the points. Identify the slope. So the slope says I can go up 4 for every one space that I move over. So one space forward, up 4. One space forward, up 4. All right. This is my line. Top line. All right, so very simple to get from point slope form onto a graph. If I look at the bottom line, actually, how about you try it first, and then check what you got against what I got. So hit pause, try to graph the bottom one, then unpause, see what's happening. All right, bottom equation, x is 7, y is negative 5, 7, negative 5. That's a point that will fulfill this. All right, so we got forward 7, down 5, out here, and then my slope is positive 1/3, which means I'm going in the upward direction, which means I'm gonna run out of space here. But backwards 3, down 1. All right, would give me forward 3, up 1, forward 3. All right, so all the way at the bottom corner of this graph, my lower equation. All right, let's look at one more. Say y plus 1 equals 1 negative 1/2 x plus 4. Hit pause, try it yourself. Unpause. What is the point that we know is on this graph? We know the point is going to be x is negative 4, y is negative 1. Alright, why do we know that this works? What happens if I do 4 plus negative 4? 0, right? 0 times 1/2, 0. What happens if I do negative 1 plus 1? 0, right? So basically, we're finding the point, x, y, that makes both sides of that equation equal 0. Okay? That's part of why this works. Negative 4, negative 1, so backwards 4, down 1. That's my point right there. And then my slope is negative 1/2, which means I go down 1 for every 2 that I go forward. Down 1, forward 2. Down 1, forward 2. Or if I was going backwards, up 1, backwards 2. Right? That's how you can graph a line given to you in point slope form. I show you a situation, pause, try it yourself, see if you can get it right, unpause, check what I do, make sure we match. If we match, smile, you got it. If we don't, bring your questions to class with me.
One last challenge for you to think through. How does point slope form? How does this formula get built directly from the slope formula that was introduced in lesson 28? You can move from the slope formula to this formula in one arithmetic step. See if you can figure that out and then tell me.